So now we are trying to solve the problem 8 of Project Euler, largest product in a series. Here we should find the 4 adjacent here the 4 adjacent number digits in the 100-digit number that has the greatest product are 9 times 9 times 8 times 9. These numbers are adjacent digits inside these numbers, which is equal to 5832. Now, we are supposed to find the 13 adjacent digits in a 1000-digit number that have the greatest product. So, and it asks for the value of that product. So, what first I did is that I copied these numbers, the whole numbers, and put them in a string. Here is a string, and the whole number is in just one line. And so here I use the new structure named big integer. Big integers are some objects that you can store in them a value of a number, and you can multiply them, divide them, and do all the valid operations with the integer numbers. So, but they are quite a little bit different because you don't multiply them by like times, or you don't divide them by this or add them in this way. So you have to do use the big integer own function. Like for example, to assign a value to a big integer number, you should use first you should define it, and then the variable name here, I named it max, or you can just name it as n, is equal to big integer dot value of, and then put their value. So and they are defined this way. And you can also give them value within a string. It doesn't have to be a number, it can be a string. Now, if you want to multiply n by a number and put it back into n, it will be n is equal to n times n dot multiply, and then here is m. M is another big integer. Like for example, you should define it before or define it down there. I will show you the both way. And this is how it comes. Or if you haven't defined m previously, you should define it here. Like instead, you can use this. N is equal to n multiply here. You should define a new big integer, so be new big integer, and then here, if you want to give the value as a string, you should put the string here. Like for example, 1, 2, 3. So it will multiply n by 1, 2, 3, and then put it back into n. And if you want to compare two big integers, it works like a strings. So you should use compare to function. So if I have n dot compare to m, so it can give me 3 results. It could be 1, 0, and minus 1. Oh. minus 1, 0 minus 1. No. It can give you a positive number, 0, or negative number. So if it's a positive number, it means that n is greater than m. So positive number n greater than m, 0, n equals to m, and negative as n is less than m. So then you just need to check if n dot compared to m is bigger than 0 or not. So if it's bigger than 0, then you know n is greater than m, and if it's not, then they are either equal or the other one is less than that. So to get to find the maximum of n and m, we can do something like this. We first need to define a big integer max as the one that we want to store the biggest one, or we can simply put the biggest one into m. So for example, we check that if n dot compared to m is bigger than 0, so n is equal to there's no difference because n is the greatest one, so nothing will be changed. So if n compared to m is less than 0 or is a negative number, it means that m is a bigger number. So m will be equal to n. Now, we want to find the 13 adjacent numbers that has the maximum product in this list of numbers. So first, I define the value L. L is actually the length of those adjacent numbers that we're looking for. So, and to make it a little bit more easy to try, I define L. So I was able to choose L as 4 to check if my answer is right or not, and then I can change it to any other value. So that L is the length of the how many adjacent numbers. So that number should be L. And then I define the value max as a big integer, which will store our value inside it. And then n is 0. N is an integer number, and then I walk. Actually, n here is our counter. So we'll check which digit are we checking now inside that big string of integers. So I check while n plus L is less than or equal to 1000. Why I used L here is to make sure that I will not check outside of the string, because the string has only 1000 digits. So if I start from the first one, I will also when I start from the first digit, I will check until the digit 13 or until the digit L here. So I should always keep my distance from the last 13 one. I cannot start with them. I can end up with them, but I cannot start with them. That's only to make sure that no outside of the range of a string happens. So I defined a new big integer p that has the value of 1. Why I set the value as 1? Because 1 times any number is that number. If I set it initially as 0, I could not multiply it by any number, because 0 times any number is always 0. So I go through those numbers. So if first I choose the first digit, like here, if it's 7, I will go to number 13. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. I guess it's until here. So it will check the number 7, 3, 1, 6, 7, 1, 7, 6, 5, 3, 1, 3, 3. So it goes all through those numbers and then multiply them by each other. So p, which was initially 1, will be multiplied by another big integer that I get it from the string in the which starts with the value of I and then I plus 1. And it will multiply the first those 13 digits, and then I will compare P with the max number. If P is greater than max, then I will put P into max. So I always keep the maximum number in my hand, and I will increase n so it goes through the end of those strings. And finally, I will print out those numbers. And then if I run it, it will print out this number. And if we check it by the number here, which I previously answered, they are similar.